kids, today we will be rounding out our focus on density. Hopefully you're feeling a lot less dense after studying this unit. I paused for all the laughter that I'm sure is happening right now. So we're going to be doing a cylinder density lab, and we will be doing density by water displacement. So hopefully you have already finished the virtual density by water displacement lab, and you have kind of an idea of how finding density by water displacement works. So now you're going to do it in real life or virtually in real life. Again, if you're a full-time virtual student. So for my full-time, this is really mostly for the full-time virtual students and or students that are absent from in class. So here we go. All right, so this lab shows how mass and volume are related, which is density. It also shows how mass and volume together, which is density, can show as a property of matter on a graph. So in other words, how it can be used as a characteristic of that substance and actually can help us identify that substance on a graph. So, it depends on your situation here. So full-time virtual, maybe you have a printer, maybe you don't. If you don't have a printer, you've got a couple of options. You can either get out a sheet of paper and head it with your name, class, period, and date, or you can download the lab sheet onto your iPad and you can fill it out with your finger, or maybe you're lucky enough to have an Apple Pen, I don't know, and do the lab that way. Either one of those methods are perfectly acceptable, as well as if you have a printer, you can just print the lab sheet from your teacher's Canvas assignment. It should have, PDF after it, or student lab document, be labeled that way somehow. So there you go. And then this is just basically the beginning of the lab. So how does a graph show the relationship between the mass and volume of different size pieces of the same pure substance? So let's take a look at that. So if the mass and volume of different size pieces of the same pure substance are plotted on a graph, then the points on the graph will fall on and there are a couple of answers that might be acceptable here, blank blank, and because of that it will show that density is a blank of that substance or matter, because the density is the blank of the line. So these are things that were discussed in the density blocks lab. So, all of this information that you learn in science really is transferable to other parts of science and also builds off of itself. So we're going to take this information and we are actually going to keep building on it for quite some time now. So anyway, hopefully you remember that from last week's lab. So if you don't, you can always ask. So here we go. Procedure and recording data. You will be looking at the pictures on the next slides and recording the measurements onto your data table. They will be in sample, initial volume, final volume, and mass order. Make sure you are recording your data in the correct column. Make sure to measure with the meniscus and use the arrows, which you'll see on the pictures, for extra assistance. Measure the water displacement, which is the final volume minus the initial volume from the graduated cylinder pictures, in milliliters. Okay, so one thing I want to make sure that you know, so you're watching the video right now, there's also a PDF version of this slideshow available on your Canvas assignment, and in that PDF version it might be a lot easier to read the measurements. It might come out a little fuzzy if you hit pause and try to enlarge the screen on this video. So just to let you know that. So procedure, you're going to make note of your sample number on the data table. And for you, virtual students, you're going to be recording the initial volume based on what you see on the picture. Obviously the sample is going to be put in the graduated cylinder for you. You're going to record the final volume of the object on your data table, and then find the mass. Again, you're going to be reading that from the picture. And then you're going to return your sample and choose another sample, and then repeat steps 2 through 4 until you have measured all of the samples of the substance and record your data using precision measurement. Okay? And then find the density. So this is what your data table looks like on your paper. And then copy this onto your paper if you're using notebook paper. So you've got your sample number, initial volume of water, final volume of water, and you're just going to go across one sample at a time. The volume of your object, again, it's right in the directions. The volume of your object is the final volume minus the initial volume. Okay? Mass in grams. You want to record in your density. And again, we really want to focus in on that precision and accuracy measurement skills. Okay, so make sure you are trying to read those instruments with as much accuracy and precision as you can. So for example, this is sample 17. So that's what you're going to record in your data table. This is sample 17's initial volume. So really try to look at what that would be, and remember to use your estimating powers as you look at that. And again, that PDF version is available so that you can see it a little more clearly. This is sample 17's final volume, and I'm going to zoom in a little bit there for you. Be very aware of what your graduations are on this cylinder. How much is it going up by? So therefore, what can I estimate to? And if you are using this to maybe help you in class, I think your graduated cylinders actually have the same graduation, so never mind. Okay. Find the mass of sample 17. So this is the mass, so make sure you're looking really carefully and you're adding those beams up, adding what the little writer markers are, denoted by the 3 arrows. And again, use those powerful estimating powers to be as accurate and precise as you can. So this would be the mass of 17. So to do this, remember, add the mass of where the beams are marked together. And now we're moving on to 18. So sample 18. Ooh, going too fast there, kids. We got our initial volume. Our final volume. Didn't make a very good meniscus on that one. It's the power of adhesion sticking to the graduated cylinder. 18's final volume. And then 18's mass. This is going to be a little difficult to enlarge, I think. Go. And then we have sample 19. Got the initial volume. The final volume. Again, be aware of what your graduations are. And cylinder 19's mass. me go back to 19's mass here. 20. 20's initial volume. Oops, there's initial. Did I get, okay, let's do 20 again here. There's 20's initial. I may have accidentally skipped over that one. And here's 20's final. And here is 20's mass. So hopefully you've got your data table all figured out. And again, if you need to go back and either look at the video or look at the PDF on those sample measurements, feel free to do that, and also hopefully you realize you can pause anytime you want to look at things a little more carefully. So, we're trying to, as we build on our knowledge of different things, there's also different skills that you're learning about, or at least reinforcing maybe what you already know in science. So along with learning about density, hopefully we're learning a little bit about graphing as we go through this unit. So one of the things that you're going to be doing, again, just like you did with the blocks lab, is actually graphing your data. So hopefully after doing the blocks lab, you have a better feel for how to do that. Okay, so we've got the directions, and again, this is on your paper. It says at this point you now have a pair of numbers for each sample, its volume and its mass. For each of these pairs, plot a point on the graph. Make mass your y-axis, volume your x-axis. Make the point neatly and accurately. Identify the point by drawing a small circle around it. If it helps, re-record your data from the data table to the small VM table to the right. So you don't have to flip pages back and forth. This is just here if you want to use it. You don't have to, okay? But you would record your volume and your mass here, and it just kind of makes it easier. It's all on one page then, and it's easier to work with. So, and the key, you do that for each sample. So maybe one is a small circle, maybe one's a triangle, maybe one is a square, maybe one is a colored in, triangle, square, or circle. You've got 4 samples, okay? So graphing your data. So we're going to add this little skill of, students, you don't do this a lot, and for some of you this may only be the second year that you've ever even really had science, and you've done graphing in math, but usually that focus is just on, what you're making. The graph is usually already set up for you. But a good skill to know is how to set up your intervals on graphs. So, again, if you need help and you just don't get this, ask your teacher. But I'm going to try to walk you through this so that you can learn the skill for yourself, and then, you always have that with you, because kids, one thing that can never be taken away from you is what? That's right, it's your education. So once you learn how to do something, then you don't really have to ask anymore, okay? So, yeah. And like in some of the classes we've talked about rounding, for example, you always have to ask, why do I round to? Well, now maybe some of you in some of the classes we've learned that you round always back to the least precise measurement. Okay, what has the fewest decimal places going out, and that's actually what you round to. You don't have to ask the teacher all the time. Unless they tell you round to the 100th or the 10th or whatever, then just do what they say, but you never have to write out all the digits on the calculator, that's for sure. Anyway, so look at how to set up your intervals, look at your data. So, setting up the intervals, that means like, what do I go by on the y-axis or the x-axis? And they can be different, okay? Just because, the x-axis goes up by 1s, that doesn't mean the y-axis has to. It can go up by 10s and vice versa. They don't have to be the same. So look at your data, and we're going to start with the y-axis, okay, mass. So what's the highest value you have for mass on your data? Okay, so you take that number and divide it by the number of intervals. And by intervals, we mean little squares. Okay, each one of those little squares is an interval. Okay, so I think it's 20. It might be 21, but we're just going to use 20 on this graph. Okay, so you take that, you do the division, and then you round up to something that is easy to work with. Okay, like you could do the exact number, but then that gets really weird when you're trying to figure out, okay, where is that exactly, you know, when adding those intervals up. And you'll see here in this case, and then make that your interval. So for example, let's say my highest mass value is 15.6 grams. Okay, so I do just what it says. 15.6 divided by 20 is equal to 0.78. Well, that would just be a pain. If I went 0.78, then 1.56, then, okay, I gotta add 7.78 to that. That's 2 point, right? Okay, so we round up to something easy to work with. So in this case, 0.78, let's just round that right on up to 1. And what we're trying to do is make sure that we use as much of the graph as we can, so we don't have some tiny little picture of what we did in the corner or all smooshed over to one side or down towards the bottom or whatever. Okay, so we're going to make that go up by ones, and then we know at least our graph is going to go up to then somewhere 15.6 or 16. So that's, you know, covering a good portion of the up and down of the graph. And then we're just simply going to repeat these steps for the volume. Okay, so I don't, you know, who knows what that actually might end up being, but you're just going to go through the same process for that. And, you know, hopefully you'll have a graph that looks beautiful and takes up, you know, a good portion of the graph. Okay, and then don't forget to label your axis with the units, just like we did on the lab last week. Put an appropriate scale, which is what this is talking about, and you got your key. It's expected that the data points may not fall exactly on the best fit lines, but if any points fall far from the lines, the basic measurements should be rechecked for mistakes. Okay, so that means if we've got some wackadoodle outliers, we probably want to remeasure. All right, moving on, we got our analysis questions. So when you're finished, in-class students, you'll hand this into the teacher. Virtual, or if you're absent, you know, the day of the in-class lab, take screenshots and submit it to Canvas. So we got our analysis questions. Examine your graph and answer the following questions. You can use your graph to make inferences about samples that you have not measured. So examine your graph. So what would the mass of an 8 centimeter cubed piece of your substance be? Okay, and it gives you directions on how to do this. To answer this, find the point on the best fit line for your sample that is exactly above the 8 centimeter cubed mark on the bottom or x-axis of the graph. So you're going to trace up from the x-axis to the line, and then it says trace horizontally to the left side to find the mass. So for you, it's going to look something like this. I'm going to go up and stop wherever that best fit line is, and then I'm going to go over from the best fit line and see what this number is. Okay, and that's going to tell me the volume of an 8 centimeter cubed piece. Okay, and then it says, just so we can tell, could a sample that has a mass of 6 grams and a volume of 5 centimeters cubed be made of the same material as your substance? What is your reasoning? So think about that. Now we're going to actually find the slope for the best fit line, okay, because we've learned last week that that slope should be close to the density. Okay, so we're going to do rise over run. Okay, so your teacher will probably have a picture up on the whiteboard in class, and again, we went over this last week. Okay, so again, you're going to have your little best fit line. Okay, so I'm going to just draw a little picture on here while we're at it. My best fit line's not going to be real pretty, so let's say that, oh, that actually turned out really well. Okay, and always know that the best fit line, like I tend to make it at a 45-degree angle, but it's not always at a 45. It could be low slope, it could be high slope. It really just depends on the density of your material. So if I'm going to do rise over run, I'm going to pick 2 points, like maybe here. And it doesn't have to be points that you've already measured. I like to pick points that kind of cross, so it's easy for me to do. So this point is what we call x2, y2. Okay, and this point is what we call x1, y1. Okay, so basically what I do is I trace over my line to the y-axis, and then I trace it down to the x-axis. That is so not straight. There we go. Hopefully you're getting the idea here. This is my rise, and this is my run. So when it says y2 minus y1, it's just this number minus this number over x2 minus x1, which is this number minus this number. Okay? And I plug that into the formula, and then I actually use my calculator to get me to the decimal value of that, and then I compare that to the density that I found for my substance. Okay, there we go. So and then it says lead is a very dense material. It's used for fishing weights. On your graph, sketch in a line showing your best guess about what will result from measuring mass and volume of several pieces of lead. Conversely, foam has a very low density. Sketch a line that looks like it might be foam. So there you go. And this is just like your best, think about what you did and, do that. And then density is a property of matter and can be used to identify unknown substances. So what you got? What did you get here? And your page actually has it all filled in. It just kind of cut off for the PowerPoint. Several pieces of metal and plastic were found at a hit and run crash scene. How could the skills you used in this lab help solve a mystery? So, there's a car crash. We don't know who did what. Maybe several cars were seen near the scene of the accident. So, how could you use this information to help you? And then for bonus, research your substance and state how it's used in real life. All of this has real applications. So, tell us how it's used in real life. And that's it, kids. So do your lab and good luck.